Hello guys, you're welcome to my channel once again. In this video I'll be talking about the schematic diagram and practical diagram of the control circuit for direct online starter of a 3-phase induction motor. I'll be giving you the circuit diagram, the symbols, and the practical diagram, the construction diagram, how it's been arranged in a panel. We have more ways of starting an induction motor, of which direct online is one of them. We have the start data, the auto starter, and the soft starter. So just stay tuned to my channel. I'll be giving you more interesting videos that will help you in your field. So these are the symbols you can see in a schematic diagram of a direct online. These are the symbols. This is a contactor, this is a circuit breaker, this is an overload with a motor. Usually after the overload you get a motor, so that's why these are attached together. Some symbols they may not be together. So this is a symbol of a lamp indicating stop light, trip light, and running light. Whenever you see this, it represents lamp. This is the coil of a contactor. If you get a contactor, you will see this. You find these terminals labeled as A1 and A2. They are the coil of the contactor. These are the part that is being energized to switch on the contactor. They represent a normally open contact. This represents a normally closed contact. This represents a stop button. A stop button usually normally closed, while a start button usually normally open. So this is the picture diagram of those symbols. This is a circuit diagram, this is a contactor, this is a motor, this is an overload, and this is a stop button, this is a start button. These are the lights, the indicator light. This is a running light, this is a stop light, and this a trip light. Now let's go to the schematics. So this is the power diagram, and this is the control diagram. When you're asked to draw a control diagram of a direct online, this is what they are looking for. And when you're asked to draw the power diagram of a direct online, this is what they are looking for. This. So you can see the incoming 3-phase. It goes to our circuit breaker. From the circuit breaker goes to our contactor, and from our contactor it goes to the overload, and from the overload it goes to the motor. Now this is the control diagram. The control diagram is usually being wired through the normally closed contact of the overload. From there it goes to the stop button. Let me show you the normally closed contact of the overload. This is an overload, as you can see. This side is normally closed. This is normally closed contact 95, 96, and this side 97, 98 is normally open. You usually wire the trip light through it, because once this overload trips, this side becomes continuous. So we now connect our lights through it to enable us know when this has tripped, and the control is being connected through this contact, so that whenever this trips, this becomes normally open, de-energizing the control. By so doing, the contactor is off and the motor is being protected. So the overload goes to our stop button, from the stop button to the start button, and from the start button to the coil of the contactor. So when you press the start button, the contactor comes on, but when you release your hand from the start button, the contactor goes off. But to make it stay on, we make use of this returning contact on the contactor. There is a normally open contact on the contactor, which is labeled as 13 and 14. You will see it when you get a contactor. Let me show you the contactor we have here. See, this is normally open. This is 13 and this is 14. This is a contact. So you just have to connect as like this from the output of the stop button to 13 and from 14 to the coil. Whenever this closes, this will close, but when this releases, this doesn't release, it remains closed. So the light, the supply now goes through this to this, and our running light, which is the green light, comes on. Now the stop light comes on when the contactor is off. This 2122 is a normally closed contact on the contactor. It remains closed when the contactor is not energized. So we use this contact to wire our stop light to enable us know when the contactor has stopped. And this is our trip light, the 9798, which is a normally open contact of the overload. It closes when the overload trips. Now this is the diagram of the direct online. You see, this is a construction diagram. You can see our contactor. You can see our circuit breaker. This is a circuit breaker. You can see it takes the three-phase supply and the neutral. You can see it, and it goes to our contactor. From the contactor goes to the overload, just like you saw in the schematic diagram, the power diagram. This is the power diagram and this is the control diagram. So you can revert back to our previous page for you to understand this, in case you didn't get it very well. So this is our motor. So like I told you, the control is being taken from the overload 95, 96, which is this. You can see the supply is being tapped from here. It goes like this, it goes like this, it comes here, it comes here. This is normally closed. As long as the overload has not tripped, this place remains closed, and our current continues. It continues, it continues. It's just exactly as the schematic diagram of the control diagram. It enters here, the stop button, comes out from the stop button, enters the start button, comes out from the start button, it goes to the coil of the contactor, the one side, which is A1. Let's see, look at it, it's from here. This is A1, this is A1, and A2 is neutral. It's neutral. This is A2. So whenever you press this button, the contactor closes and the green light comes on. Now our returning contact is being wired exactly as it is in the control diagram. You can see from here to the normally open contact of the contactor, which is the 13 and 14. From here you go like this to the coil of the contactor. Now the stop light is being wired from the normally closed contact of the contactor, which is the 2122. This is normally closed. So this is our stop button. This is our stop button. So when the contactor is not energized, that rather it is stopped, this side the current goes through and comes out here at this. You see, to energize this will come on, telling us that the contactor is off. Now when the trip light comes on, it means the overload has tripped, and here it has become normally closed. So the current flows from here, you see, to the green wire, and here. So I believe it's self-explanatory. But I will show you the construction diagram, how it's being wired in the panel. Let's look at the next. This is usually what you see inside the panel. You see it arranged this way, As you can see, it's no longer arranged in a straight line whereby the power diagram is one side and the control is one side. This might be, this is a kind of the panel. You can arrange this side. These are usually on the cover of the panel. This light and the button, they are usually on the cover of the panel. That's what will be controlling all this. This will not be the inside. This will be inside of the panel, while this is on the cover of the panel. So you can arrange it horizontally, or you can arrange them vertically. So when you open your panel, this is how the wire will be arranged. You see you wire like this, you go like this, you go like this. It's almost the same with the former diagram we just saw now, but this is just exactly how it will look like inside the panel. As you can see, you can trace it. Our stop light, this is the stop light, which is this. They normally close. It goes to this when the contactor is off, and this is our returning contact from the 13 and 14. So you can look at it very well. And this is our A1. You can see two cables coming to A1. One is from the start button and the other one is from the returning contact, which is one of these green cable. So you can see it. You can see it there. Our A2 is the neutral. This is our overload. You can see very well. This is 95, 96, which is usually normally closed. You can see when this is working, when it has not tripped, the life goes through this. But when it has tripped, the life goes through this, energizing our trip light to tell us that it has tripped, which is this. Let's see where it goes. Let's see where it goes. Look at it. Let's see where it goes. So that's it. You see, this is our trip light. So when you follow it, you will see it is in line with our circuit diagram. So this is our stop button. This is our start button. So and these are called terminal blocks. You usually see it inside the panel. I will show you the panel construction in my next video. All you have to do is stay tuned to my channel to be able to get the videos